I'm Rosco. Thanks for joining. I'll be talking about verifying smart contract source code on Etherscan, specifically for Truffle projects. So a little bit about me. I am a software engineer at General Protocols, where we're building some new innovative DeFi platforms for Bitcoin Cash. I also maintain a few other projects, such as Revoke.cash and CashCrypt. For Truffle, I've developed the Truffle assertions library, which helps with unit testing your Truffle smart contracts, and which is relevant for today. I'm going to be talking about my project Truffle plugin Verify, which helps you to verify the source code of your Truffle projects on Etherscan. So the contents of this talk, I'll begin by explaining why source code verification is important. I'll go a bit over like the traditional methods for source code verification, and then I will also talk a bit about using Truffle plugin Verify as an alternative to that traditional method. And finally, I'll discuss some of the technical details of the plugin, how it works exactly. So most importantly, you want to verify your smart contract source code to build trust in the smart contracts you're writing by allowing users to inspect the source code of these smart contracts so that they can see exactly how it works. There's some other nice features associated with it. So Etherscan generates this sort of bare bones interface for like interacting the smart contracts functionality, interacting with the smart contracts. Usually, if you have like your own project that you're building, you'll have your own front end as well. But this is just kind of like a good alternative to have that comes straight out of the box. Verifying your source code also makes the events page in Etherscan just more insightful, because Etherscan knows exactly like which events your smart contract can emit, so they can decode it properly instead of just having some like hex strings. And finally, also when you verify your source code, that means that Etherscan now also knows your contract API and makes it available. So if there are other people developing like applications around your smart contracts, they can just download the API from Etherscan, which is very helpful. I've done that in the past myself as well. So then to touch on like the sort of traditional method for verification, the way I guess it used to go. So basically you're developing your project using Truffle tools probably, and at some point you want to verify your contracts. And at that point you have to use some command line tool to flatten all your contracts. So to like concatenate all the different files together and then paste that into Remix. Then from Remix, you have to like deploy the correct contracts. So you have to like deploy it from Remix. And then when it's deployed, you have to like copy paste that same flattened code over into Etherscan. And then they have this web form where you have to fill out some other information like the compiler, API encoded constructor arguments, but also things like if you're using any libraries, you have to provide the full list of all the library addresses that you're using. So in short, that's quite a lot of manual work. So that you ideally you wouldn't want to like have to do manually. Ideally, you would want to have that automated. And I think even more importantly that it makes it so that you cannot use the built-in Truffle migration tools. So you're using this whole suite of tools like Truffle, and then in order to verify, you have to run your deployments through a browser IDE, through Remix. So that's just kind of a waste, I would say. So that's the I would say the main reason why this method is like less than ideal. So instead, if you're using Truffle as your suite of tools for development, then you should use Truffle Plugin Verify, which is a project that I developed, and that allows you to verify your source code like straight from the Truffle command line, sort of seamlessly integrated with the rest of the Truffle flow. So first up, in order to install it, you have to go through a few steps. We'll install the npm package, and then you'll have to add the plugin name to your Truffle config file. So for every Truffle project that you have that you want to use this in, you have to do those steps. It's not too difficult, but then the next step is that you will also have to request an API key from Etherscan, and that's free, but it is something you have to do. So you have to create a profile on Etherscan, and then on your profile page you can request a new API key. And then that API key can be used for Truffle Plugin Verify by adding it to your API keys list in the Truffle config as well. And so while you have to add those config steps to every new project file, you only need to generate your API key once, and you can reuse it in all kinds of in all different smart contract projects that you have. So that's basically it. After that, your installation is done, and you can use Truffle Plugin Verify, like I said, seamlessly in the same sort of flow that you're using with Truffle. So you start off, you compile your contracts, then you migrate them using your Truffle migrations that you defined there. And then immediately after, you run Truffle run verify with the name of the contract that you want to verify, and then also the network that you deployed it to. So pretty straightforward. Say that you want to verify a different deployment. That's also possible. Say you deployed a contract yesterday or a week ago, but since then you updated some things, or you ran 3 different deployments after that, and Truffle doesn't, or the Truffle artifact doesn't know the most recent, or the Truffle artifact only stores the most recent deployment. So that's why we can verify the most recently deployed one just by providing the name, but you can also add an extra address there. So like I said, if you want to verify some contract that you deployed yesterday, that will take some amount of seconds, not too long, and at some point it will output a link to your to Etherscan, to your specific contract, where you can inspect your source code. So that doesn't always work. And some of the reasons, usually when I see it not working for people, it is because they are trying to verify some contract that they deployed a year ago, and they don't know specifically which Truffle settings they used. And in that case, it's going to be very difficult to really verify the source code, because everything needs to be the same. Etherscan needs to use the exact same settings that were used when you deployed it. But so I would say the plugin is really meant to be used inside the Truffle flow. So like I said, you compile, you migrate, then immediately you verify. And if you use it like that, basically this will always work. And yeah, so it's that easy, really. Yeah, that's how the plugin works. I'm going to go a little bit in detail about how it does that. So whenever you're creating a Truffle plugin, you have access to this config object, and the config object contains basically the stuff that you have defined in your Truffle config, but also the command line arguments that are passed into the into the command, and some other things, like for example the build directory, so where your artifacts are stored, and some other things like that. And so basically we extract the stuff that we need from that config object. So in this case, that is like the network, some of the network configuration, also the Etherscan API key, and where to find the artifacts. So from there, we retrieve the correct artifact. So so we check what the name is of the contract that the user wants to verify. From there, we retrieve that artifact and we extract exactly the data that we need from there. So that is basically the deployed address, some of the metadata, and there's some other fields in there that we have to extract. And from there, we convert that data into a so-called standard input JSON, which is basically a standard format that the Solidity compiler can use to recompile these files in exactly the same way. Besides that, we also fetch the constructor arguments. And how we do that is we retrieve the deployment transaction, which is the first transaction for a smart contract. And from that transaction, we extract only the piece that includes the constructor arguments. And basically, these are the two pieces of data that Etherscan needs to verify the data. So basically, they need to compile the smart contracts in exactly the same way as you did, and then they need to know which constructor arguments you provided. So once we have that data, we build a request to Etherscan, where we provide things like the API key and the input JSON and some extra data that Etherscan needs. And we send the whole verification request off to Etherscan. That usually takes a while, and you have to check back yourself. So you have to pull for your verification status. And so we just do that every second in the plugin. So every second we pull again until the verification status is no longer pending. And at that point, we return the status. That's basically it. So yeah, I hope that helped you guys with verifying your own contracts. If you want to check it out and you want to like read a bit more, I've set up this small list of further reading. The top link is an article on my website that basically explains the same concepts that I talked about right now. So if you just want to like read it back, that's a great article to read. You can also check out the plugin source code on GitHub, and the final link is the slides that I used for this presentation. So you can also check that back on my website. That's it. So are there questions? I see that Tyler said, what specific data in the artifact does the plugin use for verifying the deployed data? Which deployed, what? I'm not sure if I understand the question. Maybe, how does it work? Can you come on the screen as well? Is that how it's supposed to be? Like you raise your hand and then you can ask it, or I don't know. Does it work? clicked.
Oh,
all right.
Hey, Rosco. I was just curious, like, what specific? So you're verifying a contract that I deployed.
Can you guys see Tyler?
I'm sorry.
I can't.
Oh,
I'm not seeing Tyler.
Oh, well, I can type it in the chat.
Oh wow. Okay. I can't. So that's great. Okay. So suppose you deploy a contract. I still can't see or hear you, so I guess we'll have to do it through the chat. That's all right, Tim. No worries. So you're saying, suppose I deploy a contract and I want to verify it. The plugin gathers info from my artifact file, right? And you're asking which info it gathers from the artifact? All right, so a few different things. Mainly it looks at, so first of all, it looks at the deployed addresses. So it checks, okay, does this contract have a live deployment, and what is its address? Then it also looks at the compiler data. So I think in the artifact it says like this was compiled with Sulk version something like 0.6.11 or something. And so we take that, and most of the rest of the data we get from like the metadata field, which includes metadata. I guess that Truffle gets it from the Solidity compiler itself, and basically that includes a lot of like all the data that we need to properly put that standard input JSON, the Solidity standard input JSON together. But it's just that the formatting of the data is a bit off, so we have to, or I still have to, like transform the data into exactly what Etherscan expects. Does that make sense? All right, cool. So actually, this is the way it works right now, as of like version v0.5 of the plugin, and that was only released like I think a week or two ago, and before that it didn't actually use the standard input JSON, but instead you would have to flatten the source code. So I used a tool, like a JavaScript tool that would then flatten the source code, and then you use that flattened source code. But using this input JSON, you get you can see all the files separately on Etherscan. So then you can see exactly which parts of the code come from which files. So it's just a bit more insightful than just having like a huge flattened source file. So yeah, any other questions? So Jeremy is asking, for Open Zeppelin contracts, do you also flatten those to upload? So like I said, so for the previous version, whenever you're like importing, so whenever you're importing Open Zeppelin contracts, for example, or other library contracts, in the previous version, it would also flatten that and include it in the huge flattened file. But right now, it just imports them as separate files. So I've tested this with some different Open Zeppelin files, and it appears to be working. So basically, say you're importing like an ERC20 token from OpenZeppelin, then that will all be in its own separate file if you look at Etherscan, and then whatever your own source code is will be also in its own separate file, and it will show that you're importing from OpenZeppelin. That makes sense. Does that answer the question, Jeremy? Cool. So yeah, so feel free to check it out. Like, see if that makes it easier for you. And like I said in the talk as well, that like if you're not using Truffle, then, or like not mainly using Truffle, then it's probably not really a good idea to try to like verify your contracts using this plugin and like try to like fit it in there. Like it's really used to be, or like meant to be used with the rest of the Truffle flow, and otherwise it's still going to be like messy and it's going to be difficult. So.